All right, we are working on a unit about matrices, and it's time to review what we've learned so far. So look at problem number 1. Let's remember how we find the determinant of a 3 by 3 matrix. We actually learned 2 methods, but the one I'm going to use is the one where we recopy the first 2 columns. So we're going to have -2 and -5 and 8, and then 4 and -1 and 1. All right, recopying the first 2 columns. So what we do is we do the down diagonals minus the up diagonals. So there's a down diagonal, there's a down diagonal, and there's a down diagonal. All right, so I am doing the down minus the up diagonals. So the down diagonals, and here I'm multiplying, so this is going to be -6, and then this is going to be 64, positive 64, and this is going to be -15. All right, multiply, multiply, multiply. Now it's time to do the up diagonals, and the up diagonals are like this. There's 1, there's 1, and there's 1. So the up diagonals will be -24 and -4 and positive 60. All right, so we just have to calculate all this out, and that is going to be the determinant. (11). So this particular determinant is 11. All right, let's see what else we've learned. You know what, I forgot that it said graph the triangle. Yeah, I'm not really asking you to graph the triangle right now. Find the area of the triangle with these vertices using the determinant. So as far as finding the area, what we do is we use a formula that said if we do plus or minus 1/2, and then we do the determinant of a matrix that we get by using these ordered pairs. So 4, 1, 2, -5, 8, -3. Okay, those are my 3 vertices of the triangle, and then I'm supposed to create the third column using all 1s. All right, so if I calculate and evaluate this, that should give me the area. I'm using the straight lines here because that means find the determinant. So since I need to find the determinant, I'm going to do just like we did on problem number 1, and I'm going to recopy these first 2 columns. So this is going to become 4, 2, 8, 1, -5, -3. So I need to do the, I've got plus or minus 1/2. All right, but now I'm going to do my down diagonals minus my up diagonals. Okay, my down diagonals are here, here, and here. So that's going to give me -20 and positive 8 and -6. And now I need my up diagonals. So there's an up diagonal, there's an up diagonal, and there's an up diagonal. So my up diagonals are negative 40 and negative 12 and 2, positive 2. Okay, so I just need to evaluate all this and then take half of it. So I'm going to leave the plus or minus 1/2 out there for a minute, and I'm just going to evaluate all of the rest of this. Okay, so I've got negative 20 plus 8 minus 6, and that's minus negative 40 minus 12 plus 2. Oh, I said negative 40, but then I put negative 4, didn't I? All right, so I'm getting 32. All right, but if I take half of that, that's going to give me an area of 16. All right, there you go. Moving on to number 3. Find the inverse of the following matrix. Okay, All right, the inverse is a two-step process. So, I mean, the formula for the inverse is like this. You know, if this is matrix A, then the inverse is going to be 1 over the determinant, okay? And then we reverse and negate. Reverse the down diagonal, so this would be 6 and 4. And then negate the up diagonal, so that would be negative 2 and negative 7. So, fine, I did my reverse and negate, but I need to divide all of these by the determinant. That's what's going on here. So that means I need the determinant really before I do anything else. So off to the side here, let's calculate the determinant. So the determinant, again, is the down diagonal minus the up diagonal. So that's going to be, you know, we're talking about 4 times 6 minus 2 times 7. So we're doing 24 minus 14. So that is going to be 10. All right, so that's your determinant. Okay, so that means this is 1 over 10. Which really means I'm just dividing all of these things by 10. All right, so that means for a moment there I've got 6 over 10, and I've got negative 7 over 10, and I've got negative 2 over 10, and I've got 4 over 10. But then I need to reduce these properly. So 6 over 10 reduces down to 3/5. Okay, and negative 7 over 10 does not reduce. This is going to be negative 1/5. And this will be 2/5. So this would be the inverse matrix. So that's how you do number 3. All right. Let's take a look at number 4. Find B and C so that the following matrix has no inverse. Well, no inverse. The only matrices that have no inverse, if it will have no inverse is if the determinant is 0. Or that's the only way a square matrix is going to have no inverse. So we're looking for a value of B and C that would cause the determinant, all right, and of course I'm calling this matrix A, but we want the determinant to be 0. So, well, let's see. if the determinant of the matrix is going to be 0, well, what is the determinant? Remember, the determinant we get by doing the down diagonal minus the up diagonal. So that means the down diagonal, which is negative 14, minus the up diagonal, which is BC. Down diagonal minus up diagonal must equal 0. All right? The determinant would then be 0, and I'd have no inverse. Remember why this is before I go any further. I don't want you just to memorize, okay, no inverse, that means the determinant is 0. Understand why. Look back at problem number 3. When we were calculating the inverse, the first thing we needed was the determinant. All right? Imagine that instead of 10, this had been 0. Then we'd have 1 over 0. You can't divide by 0. That's why you can't do the inverse if the determinant is 0, because you'd wind up dividing by 0. Okay, so back to this. So we need a value of b and c that will make this true. Well, you could look at it this way. If I've got negative 14 minus bc, and that's going to equal 0, how about we add bc to both sides? So that means negative 14 must equal BC. So there are many correct answers. Just pick a value of B and C that will make a negative 14 when you multiply. So for example, 2, if B equals 2 and C is negative 7. All right, that would make negative 14. Or B equals negative 2 and C equals 7. All right? Or B equals 7 and C equals negative 2. All right, we could switch these around. Or we could have done 1 and 14, like B is 1 and C is negative 14. Anything that's going to multiply together to give you negative 14 would be a valid choice. Okay, so many answers. Okay. All right, I think this is the last problem, so this is a pretty short homework assignment. Very unlike me to give you such a short homework assignment. Anyway, use matrices to solve the system of equations, show all work. So the way that you can use matrices to solve a system of equations is you set up a matrix equation. So I could build a matrix equation like this. 2, negative 4, 2, and 2, 1, negative 1, and negative 4, negative 1, 2. Okay, so that's going to be x, y, z. And that will equal negative 1, negative 2, and 5. So you've got your matrix of coefficients, and your variable matrix, and your constant matrix. And let's label these. Let's call this matrix A, and this X, and this B. Okay, so what we have right now then is we have AX is equal to B. And what we realize is if AX equals B, then X is going to equal A inverse times B. And X is what we're looking for. So what we need to do is we need to do A inverse times B. All right, so there's A, and so we need A inverse. Now, I have not taught you how to find the inverse of a 3 by 3 matrix without a graphing calculator. So, for now, that's what's going on here. I'm giving you the inverse of this matrix. All right, it says right here, this is the inverse coefficient matrix. So that's my way of telling you that this is A inverse. Okay, So X should equal A inverse times B. So what we need here is B. All right, if I do A inverse times B, that should give me my variable matrix. So B is -1, -2, and 5. Okay, so what we need to do is multiply the A inverse times the B and see what we get. Now understand, oh, all right, sorry, that was my wife on the phone. Okay, so yeah, so we need to multiply. Now remember the way we multiply two matrices. We have to pay attention to what the shape of the matrix is going to be. And so you know this is a 3 by 3 matrix and this is a 3 by 1 matrix, which means that the result should be a 3 by 1 matrix. So our answer should be in this form. It should be like element 1, 1, element 2, 1, element 3, 1. So we just need to find each of these. So let's just set about doing it. So if I want to find element 1, 1, for example, that is row 1, it's a big row. It's row 1 times column 1. All right, so it's this times this. So let's just go ahead and do that. So row 1 is 1/6 and 1 and 1/3. So that's row 1. Column 1 is -1 and -2 and 5. So that's going to give me -1/6 and -2 and 5/3. And we're supposed to add all this up, so here we go. So -1/6 plus -2 plus 5/3. So I get -1/2. All right, so that means that is my first element. So I'm going to go ahead and fill that in. -1/2. All right, let's go for another one. So if I want to find element 2, 1. Okay, so that means I'm dealing with row 2, column 1. All right, so row 2, that's going to be 0, 2, 1. And column 1 is -1, -2, and 5. So that is going to give me 0 and -4 and 5. Okay, and that's 1. So that gives us our second element. Is 1. So now we just need our third and final element. Okay, so we are talking about element 3, 1. And element 3, 1 is the third row times the first column, 3, 1. Okay, so third row times first column. So third row, we are dealing with 1/3 and 3 and 5/3. Okay, that is the third row. Now, that same old first column is -1 and -2 and 5. So that is going to give me -1/3 and -6 and 25/3. Okay, so I'm supposed to add that up and get an answer. So let's do that. So here I go, negative 1/3. Oh, hit it twice. All right, negative 1/3 plus negative 6 plus 25/3. So that's 2. All right, so that gives me my third and final element. Which is 2. So please understand that what we just found, all right, we did all this to solve for matrix X. So we found matrix X. But remember, right from the beginning, this is matrix X over here. Matrix X is the variables X, Y, and Z. So that means in order, what we have is X, Y, and Z. So this is X, and this is Y, and this is Z. Okay? So I could write this as an ordered triple as negative 1/2, comma 1, comma 2. So that would be the answer. So that is how you can solve a system of equations using matrices. Now, just be careful. I'm judging you on more than just the answer. You know, I've taught you other ways of solving this, and so I'm looking for your matrix equation. All right? I'm looking to see all this multiplication, your rows and columns, and I'm looking to see your A inverse times B equals the result. I'm looking for the form. All right. I will see you on the next video.